Hi everyone, welcome to Numeric Learning. So in today's video we will be seeing an important 3-mark question from trigonometry. The question is, if cosecant theta minus sin theta is equal to a cube and secant theta minus cos theta equal to b cube, prove that a square b square into a square plus b square equal to 1. Let's write what is given. What's given? Given is nothing but cosecant theta minus sin theta equal to a cube. Cosecant theta is nothing but 1 over sin theta. Minus sin theta is equal to a cube. Take the LCM. So you have sin theta. Okay, numerator you will have 1 minus sin square theta. Okay, sin square theta equal to a cube. What is 1 minus sin square theta? It is cos square theta. Okay, so cos square theta divided by sin theta is equal to your a cube. Okay, take cube root on both the sides. Okay, take cube root on both the sides. So what would you get? A is equal to, when you take the cube root of cos square theta, right? It's nothing but cos square theta whole raised to the power 1 by 3. Correct? Okay, which is nothing but cos 2 by 3 theta. Okay, so cube root of cos square theta is nothing but, this is raised to the power 1 by 3, to the power 1 by 3, and then it gets multiplied, the power gets multiplied. Okay, 2 by 3. So here you will have cos 2 by 3 theta divided by the same way. Okay, you'll have sine 1 by 3, right? 1 by 3 theta. Okay, now take square on both the sides, because in our question you need a square, right? So let's square on both the sides. Squaring both sides. So what will you get? A square equal to, when you square, okay, cos 2 by 3 theta the whole square. So again the powers get multiplied. So you will have cos 4 by 3 theta divided by sine. So you have sine 1 by 3 theta whole raised to the power 2. So it will be sine 2 by 3 theta. That's your a square. Okay, so same way let us calculate what is the very similar way. Let's calculate what is b square. Okay, I'm going to do it adjacent here itself. Okay, so you are given sec theta minus cos theta equal to b cube. Sec theta is nothing but 1 over cos theta minus cos theta equal to b cube. Again take the LCM, cos theta, so you'll have 1 minus cos square theta equal to b cube. What is 1 minus cos square theta? It is sin square theta. So sin square theta upon cos theta equal to b cube. The same way you have to take cube root on both the sides. So you'll have b is equal to sine 2 by 3 theta divided by cos 1 by 3 theta. Again you take square on both the sides. Okay, so these will continue here also. So b square is equal to sine 4 upon 3 theta divided by cos, you have to multiply it with 2, right? Because you're squaring. So cos 2 by 3 theta. Okay, now take the LHS part. You have to prove something, right? Prove a square b square into a square plus b square equal to 1. Let's take the LHS part alone. Okay, taking the LHS. It is nothing but a square b square multiplied by a square plus b square. Let's write it. What is a square? Cos 4 by 3 theta divided by sine 2 upon 3 theta multiplied by b square is nothing but sine 4 upon 3 theta divided by cos 2 by 3 theta, okay, multiplied by, write down cos 4 by 3 theta divided by sine 2 upon 3 theta plus, right, as such, what is b? B square, sine 4 by 3 theta divided by cos 2 by 3 theta. Okay, now comes the important step. Okay, so what is cos 4 upon 3 theta divided by, see, cos, okay, so you are having cos 4 upon 3 theta divided by, look at this, cos 4 by 3, cos 2 by 3. So the powers will get subtracted. Okay, so you'll have minus 2 by 3 theta in the numerator. Denominator you have sine 2 by 3 will go up. Okay, so you'll have multiplied by sine 4 by 3 minus 2 by 3 is 2 by 3. Okay, so this is what I'm going to write. When you simplify, it is very similar to a to the power m by a to the power n, which is nothing but a to the power m minus n. So here what you will have, cos 4 by 3 theta divided by cos 2 by 3 theta is nothing but 4 by 3 minus 2 by 3, which is nothing but your 2 by 3. Okay, so you will have cos 2 upon 3 theta multiplied by, same way, sine 4 by 3 minus 2 by 3 is 2 by 3 theta. Okay, and then the ones which are within the bracket, take the LCM. So you will have sine 2 by 3 theta into cos 2 upon 3 theta. Now be very careful when you are taking the LCM. So here what you have, you already have sine 2 by 3 theta. So you will have to multiply cos 4 upon 3 theta multiplied by cos. So when you multiply, the powers get added, right? So cos 4 by 3 theta multiplied by cos 2 upon 3 theta, right? So here, let me write it neatly, is nothing but cos 4 by 3 plus 2 by 3 theta, which is nothing but cos 6 upon 3 theta, which is nothing but cos square theta. Okay, so the numerator will have cos square theta plus the same way, right? You already have cos 2 by 3, 2 by 3. So what is left is sine 2. This will get multiplied with the numerator here. So the powers will get added. Sine 2 by 3 theta multiplied by sine 4 by 3. So 2 by 3 plus 4 by 3 is 6 by 3, which is sine square theta. Okay, sine square theta. Correct? Okay, now what will happen? Now it's very easy. You're almost done. So sine 2 by 3, sine 2 by 3, cos 2 by 3, cos and sine will get cancelled as it is because it's a product. Numerator is nothing but cos square theta plus sine square theta. So you can just write sine square theta plus cos square theta is equal to 1, which is nothing but your RHS. Hence proved. Okay. So it's a very, very easy question. Just that you have to be very careful when you are solving a cube for a square. Okay, so from the given question, convert everything to sine and cos and find out what is a square, find out what is b square. Try doing it once the way I have done it. So once you find out a square and b square, you just have to plug in the values of a square and b square in your LHS part. Okay, and then simplify, solve it, take LCM, and finally you will arrive at something called sine square theta plus cos square theta, the trigonometric identity whose value is 1, and that is equal to your RHS, hence proved. So this question is for 3 marks. Do try it yourself once, pause the video, do try it and let me know if you were able to do it yourself independently. Happy learning and all the very best. Thank you. Do share, do subscribe.